Hello and welcome to another installment of the Algebra 1 videos. This is section 5, and this is a section over the cube root function. So last one we talked about the square root. In this section we'll talk about the cube root. We're going to graph the cube root function in translations and reflections of it. We're going to state the key features of the cube root function in the translations and reflections of it. So let's talk about what a cube and cube roots are. So when we talked about square roots, okay, square roots is when you, and let's write that down over here, square roots, you multiply something by itself twice. So multiply by itself twice, okay, and square and square roots multiply by itself twice. Okay, you're dealing with 2. Okay, when we're talking about cube and cube roots, that means that you're multiplying a number 3 times. So 4 cubed means you're taking 4 times 4 times 4, which is going to give you 64. Okay, and then the cube root is the opposite, okay, of cubing a number. So the cube root is the opposite of cubing a number. Okay, and cubing a number is what you did up here, multiplying it 3 times. So the cube root of a number is a number that when multiplied by itself 3 times, let's change this to 3 times, okay, in the results in the number that appears under a cube root symbol. So, you know, when you had, and let's just look at something here for just a second. Let's think about the square roots. Okay, when you had, say, 4 squared, okay, it gave you 16, right? And when you took the square root of 16, you got 4. Okay, usually there's no number here, but there really is a small little 2 that you can put there to talk about the square root. Okay, and that's where this little 3 comes in. Okay, this little 3 indicates you're doing the cube root, okay? And so you're wondering, and then you say to yourself, okay, well, what is the cube root of 64? Well, what number multiplied by itself 3 times gives you 64? And the answer to that question is just going to simply be 4, okay? All right, so now let's talk about square roots versus cube roots of negative numbers, okay? And so when we have this, okay, square root of a negative number, that's something that you can't do. So I'm going to write that we can't do this. Okay? And the reason why is because if you take either negative 8 and you square it, meaning you're going to take negative 8 times negative 8, that's going to give you positive 64. And if you take 8 squared, then that's going to give you 8 times 8, which is going to give you 64. Okay, and the reason why is because anytime you square a number, the result is going to be positive. Okay, so you can't take the square root of a negative number. However, cube roots of a negative number you can do. Okay, and if you were to say take the square root, or cube root, I'm sorry, of negative 64, it would give you negative 4. Okay, and the reason why is because if you take negative 4 and you cube it, okay, that's negative 4 times negative 4. This gives you positive 16 here. But then when you multiply that by another negative number, it gives you the result of negative 64. So you can take the cube root of a negative number. This you can do. Okay? But you can't do it otherwise. All right? You can't do it for a square root. So let's take a minute and let's take a look at the cube root function, okay? And let's just think about something for a second. Okay, so what we want to do here is we'd want to find the cube root of negative 8, all right? And let's kind of just look at that over here. I'm going to do this work. The cube root of negative 8, all right? And let's think about that. I want a number that when you multiply it by itself 3 times gives you negative 8. And that number is going to be negative 2. Okay, so I'm going to write that this is negative 2. Okay, the reason why is because if I take negative 2 times negative 2 times negative 2, that's going to give me negative 8. Okay, so this value here is negative 2. Okay, what about the cube root of negative 1? Okay, some number multiplied by itself 3 times to give you negative 1. And that answer is going to be negative 1. Okay, the reason why, if you take negative 1 times negative 1 times negative 1, negative 1 times negative 1 gives you positive 1, times another negative gives you a negative 1. So this is negative 1. Okay, they have the point 0, 0, they have the point 1, 0. And then what about 8? What if I took the cube root of 8? All right, what number multiplied by itself 3 times is going to give you 8? And that number is 2. So the cube root is 2. So here's what you have. Okay, you have the point negative 8. So we can graph these now. Okay, here's our x column, here's our y column, or our function value column. So the point negative 8, negative 2 translates over here to the point negative 8, negative 2. So I'm going to plot that point here. Okay, same thing with the point negative 1, negative 1. That's right about here. Okay, we have the point 0, 0. And we have the point 1, 1. And then we have the point 8, 2. So your graph ends up looking like this. All right, so the thing that you have to consider here is now what is your domain and what's your range? And here's the deal. When you look at this function here, okay, the question is, can I plug in positive numbers for x and get y values? Yes. If I plug these numbers in, I get y values. If I plug in 0, do I get a y value? And the answer is yes, I get 0. If you plug in negative numbers into this x, do you get y values that pop up? The answer is yes. Okay, so the domain is all real numbers. All real numbers. Okay, where it goes from negative infinity to positive infinity. Okay, the range is the same thing. Okay, if and you kind of have to look at the graph and you have to say to yourself, okay, if I plug in x values, as x gets big, my y values are going to grow and get bigger. Doesn't look like it, but that's what's going to happen. Same thing over here. If I plug in negative x values, the further and further I go to the left, the further down I go. So my range is also all real numbers. Okay, going from negative infinity to positive infinity, which is a change from what we had on square root functions. Okay, let's look at the next page. All right, so let's talk about reflections of the cube root function. And so what we have here is we have the function f of x. This is our parent function. This is just your general cube root function that looks like this. Okay, and then you have this new function g of x, where you have the cube root of the square root of negative x. So the only thing that's negative is the input, is your negative x, okay? Now this is a reflection over the y-axis, and I want you to see what happens, okay? If I plug negative 8 into negative cube root of negative x, okay, it's going to turn that into, okay, let me show you. If I do g of negative 8, okay, that's the cube root of negative 8. Okay, the opposite of negative 8 is going to be just the cube root of 8 then, which then just gives you 2. Okay, and so things are flipped. So if I plug in negative 8, I get a value of 2. Okay, if I plug in negative 1, I get a value of positive 1. Okay, if I plug in 0, I get 0. If I plug in 1, I get negative 1. If I plug in 8, I get negative 2. So you end up getting this. You get this graph that's been reflected over the y-axis. Okay? So that's similar to what we had when we had like absolute value functions and all that other kind of stuff. Okay? Now the next thing that we have is a vertical translation. Okay? And what I'm going to do here, and this is the number that goes out on the outside. Okay? So what I have is, if we talk about our parent function, if I plugged in -8 on our parent function, we get a y value of -2. Okay, but what I want to do here is I'm going to add 2 to each of these. So I'm going to move this up. I have these points on the graph. Okay, and each of these points are going to get translated 2 units up. Okay, and so when I plug in -8 over here, normally you'd get -2, but then if I add 2 to that, that's going to make it a y value of 0. Okay, if I plug in -1, normally it'd give me a y value of -1, but I need to move it up 2 units, so it gives me a value of +1. Okay, if I plug in 0, I get a y value of 0. Okay, add 2 to that, it's going to give me a value of 2. Okay, here, if I plug in a value of 1, you normally would get 1. If I add 2 to that, it's going to give me a value of 3. Okay, and then if I plug in 8, all right, that would give me a value of 2, but then if I add 2 to that, it's going to give me 4. All right, so you're going to get this. Okay, if we plot those points, -8, 0, -1, 1, 0, 2, 1, 3, and then 8, 4. Okay, we're going to get a graph that looks like that, that's just shifted up 2. Okay, so, and that's the same thing that would happen if you did this to any other function. It's just going to shift it up or down. Okay, all right, and it says, all right, this is kind of just some generic stuff. It says the equation of a vertical translation. Cube root function has the, g of x is equal to the cube root of x plus k. K is positive, then we move it up. If k is negative, we move it down. Okay, so it's the same thing we had in any other translation. Okay, if it's a number that's added on the outside, okay, that's kind of by itself, it's just going to move it up or down according to that sign. Okay, so on this page, we want to talk about the horizontal translations of a cube root function. So what I have first is, and let's talk about this. Whenever you do horizontal translations, okay, those are going to be operations underneath the radical symbol. Okay, so I'm going to write that. Horizontal translations indicate operations under the cube root symbol. Okay, and those are going to be opposite. So in big bold letters, it's going to be opposite. All right, so what I'm going to do, if I look at this and I see a cube root function, g of x is equal to the cube root of x minus 2, because I have the -2 underneath my cube root symbol, then really what that's going to do, and let me do this. Okay, the -2 means we're going to move 2 units right. Okay, and that's what that means. All right, and the reason why, if we kind of go over here and we kind of plug these values in, let's just do that real quick. If I plug in -6, okay, g of -6 is going to give us the cube root of -6 minus 2, which gives us the cube root of -8, which then gives us a value of -2. Okay? If I plug in 1, if I do g of 1, then that's the cube root of 1 minus 2, which gives me the cube root of -1, which gives me -1. Okay? And so then if we do g of 2, that's the cube root of 2 minus 2, which is the cube root of 0, which gives you 0. Okay, if you do g of 3, then that's going to give you the cube root of 3 minus 2, which is the cube root of 1, which just gives you 1. All right, if you do g of 10, cube root of 10 minus 2, which gives you the cube root of 8, which gives you 2. All right. So let's go ahead and plot these points then. I know that's kind of a lot of math, but that's how you can generate any table of values. Okay. But if I plug in negative 6, negative 2, that's this point right here. Okay. If I plug in the point 1, negative 1, that's this point here. Okay, if I plug in the point, oh, whoops, that's not that point. Negative 1, 1 is here. Okay. If I plug in the point 2, 0, that's right here. Okay, plug in the point 3, 1, that's right here. Wait. That's right here. Okay, if I plug in the point 10, 2, that's the point up here. So you end up getting this as a result. Okay, and how you get that is you take each of these points and you move them over 2. Okay, each of these points move them over 2. This point moved it over 2. This point moved it over 2. This point moved it over 2. Okay, so it's 2 units to the right. So, to, just talk about it, if h is positive, okay, we move it to the right. Okay, if h is negative, move it to the left. So basically what it means, whatever the operation is, okay, do the opposite. Okay, and that's going to move it either to the left or to the right. Okay, so let's take a look at okay, let's look at the next one. Okay, let's go ahead and just graph this one. Now what I know is that I have this operation under my radical of negative 2, and I have this operation out here outside of the radical where I'm going to add 2. So this means I'm going, this plus 2 on the outside means I'm going to shift up 2 units. Okay? And the negative 2 that's on the inside means we're going to shift right 2 units. Okay, so what I want to do is I'm going to take each of these points that we have on this parent function, okay, the ones that we know, okay, and those are the points negative 8, negative 2, negative 1, 1, 0, 0, 1, 1, and then 8, 2, okay. And so what I'm going to do with those is I'm going to move each of these points 2 units up. So I'm going to do this, 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 and I'm going to do that. Okay? And then I'm going to move them 2 units to the right. Okay, so over there, and then I'm going to plot a point. So each of these I'm just going to move over 2 units. Wait a minute. Okay. So when I plug in the point negative 6, as a result, I get 0. Okay, when I plug in 1, I'm going to get a positive 1 out of that. Okay, if I plug in 2 here, I'm going to get a value of 2. Okay, if I plug in 3, I get a value of 3. And if I plug in a value of 10, it's going to give me a value of 4. So it's a little weird, but we're just moving these graphs up, down, left, and right is the idea. So I hope you enjoyed this video. I know it's not the most fun and exhilarating one I've made, but there we go. See ya. Bye.